Welcome back. So we're on problem number 9. In the figure above, AD is equal to 1. So AD, this distance right here, this is equal to 1. DC is equal to square root of 3. So this distance right here is square root of 3. What is the value of Z? And they say, note, it's not drawn to scale, right? Because this is longer than this, but it looks the same. Okay, so they want to know what the value of Z is. So what can we figure out? Well, the one thing that pops out at me is, well, these are both right triangles, so this is going to deal with right triangles. And the first thing we see is that these two angles are the same. So if these two angles are the same, and this is a right angle, well, we don't even have to know this, but we immediately know this is a 45, 45, 90 triangle, right? Because the angles have to add up to 180. Two of them are the same. You could say 2x plus 90 is equal to 180, and solve for it. But what you also know is that this is an isosceles triangle where two sides are the same. I don't know if you remember from geometry class that if you have a triangle like that and this angle is equal to this angle, then this side is going to be equal to that side, right? That's just, I forgot what the property is called. I think it's just equal angles equal sides, or base angles, well, whatever. Hopefully you remember that term in geometry. So if in this case these two angles are the base angles, so if this is 1, then this is also 1. This BD is also going to be 1, right? And this is going to be, whatever, square root of 2 or something. So now, if we look at this triangle, something interesting should pop out at you if you're familiar with 30, 60, 90 triangles. This side is square root of 3 times this side, right? What do we know about 30, 60, 90 triangles? And you could even turn back to page, if you don't remember, they even give it to you, right? They even tell you right here that if you on a 30, 60, 90 triangle on page 423, they draw it out for you actually. They say if you have a 30, 60, 90 triangle like this, and this side is 30, and this side is x, then this side is going to be x times the square root of 3. They literally give that to you on page 423 when they give you their formulas, right? So this side is 1. This side is 1 times the square root of 3. So Z must be 30 degrees. It's a 30, 60, 90 triangle. And if they asked you why, this would have been 60 degrees. And then, if you wanted to know what the this side would have been, it would have been 2, just using 30, 60, 90 triangles. All right. Let's move to number 10. Hopefully that's not too confusing. If it is, just review 30, 60, 90 triangles and look at that formula on page 423. Number 10. If 30% of 40% of a positive number, is equal to, so 0.3, 30% of 40%, so 0.3 times, and I don't want to use times because I'm going to use x for the number. So 0.3 times 0.4, so that's 30% of 40% of a positive number, so that's x, is equal to 20% of w% of the same number. So that equals 20% of w%, right? So if it's w%, then we could write that as, w over 100, right? w%, right? So if w is 50, that would be 50 over 100, or 0.5, right? Times x. Well, we can divide both sides of this equation by x, and these cancel out. And then we just literally solve for w. And actually, I probably didn't even have to write it as a decimal. I mean, 30% of 40% of something. Well, we can't just multiply the decimals, right? What's 3 times 4? It's 12. There's two numbers behind the decimals. So it's 12, or 12, which is also 12%, right? 12% is equal to, and then we say 0.2 times what w? What number? Well, let's say times w. Well, I shouldn't write w. I'm going to write this as y, and I'll tell you why. Because this will give w% as a decimal, right? So I'm just saying 0.3 times 0.4 is 0.12, And that's the same thing as 0.2 times what? Well, you divide both sides by 0.2, you get y is equal to 0.12 over 0.2. And that is equal to what? That is equal to 6.6. And you could review decimals if that didn't make a lot of sense to you. So that equals 0.6. So y is 0.6, or w percent is 0.6, right? So the same thing as 0.6 is 60%. So the choice is B. 60% B. That might seem a little complicated, and the tricky part is really just making sure that you're not, using decimals and assuming that that's a percent or vice versa. The important thing is we took 30% and 40%. When you multiply those two together, that's the same thing as 20% times W percent. And I liked to put it all in decimals. You could have put it all in fractions as well, actually. That actually probably would have been the easiest. You would have said, 30% is 3/10 times 4/10 is equal to 2/10 times W over 100, right? I mean, I took a zero. You could have said 30 over 100, 40 over 100, like that, right? And then, this actually would have been easy because you could have just taken the hundreds off of both sides. You said 30 times 40 is 20 times what? And then you would have gotten W is equal to 60. Actually, that's how I should have done it. But anyway, hopefully I didn't confuse you too much. Okay, next problem. Notice I do these things in real time. So the negatives is maybe I don't give you the most optimal solution at first, but I think the positive is that you see how someone, you're not seeing just the clean solution. You're seeing how someone, the thought process that they go through when they tackle these problems. And I think that that's actually a super useful thing to see because, when you see these very polished presentations, that person did the problem ahead of time. And so they just give you the answer, but they're not showing you kind of how they stumbled upon the answer. So I can only hope that this is useful. All right, number 11. This looks exciting. Okay, I'll switch colors to this. Number 11. Let me draw this thing. And I have the perfect tool to draw it. Let's see, so. Oh, no, I didn't want it like that. No. Let me see. I want it like this. I want it like that. So I have a big rectangle like that. And they took half of it like that. It looks. No. Edit, undo. Edit, undo. I gotta go half. My eyes aren't working. So it's roughly half. Like that. And then they take a half like this. And then they take half like this. Or they keep doing it. Half like that. Then they take a half like this. Then they take a half like that. And just drawing this is fun. Okay, I think this is what they have. And then they actually shade in that last one. So let me shade in that last one. No, I shaded in with white. But anyway. In the figure above, rectangle ABCD, that's the whole thing, is made up of 7 non-overlapping rectangles. 7. The two smallest rectangles have the same area, so these two have the same area. Each of the other rectangles have twice the area of the smaller rectangle. Okay, and it looks that way. The area of the shaded rectangle is what fraction of the area of the rectangle ABCD? Well, let's just chug through this. So let me find a suitable color. So if this is x, I'm still using the rectangle tool. If this is x, then this is going to be x. This is 2x, right? If this is 2x, then this is 4x. Because they say that each larger one is twice the previous, right? So this is 4x. So this is going to be 8x, right? So then this is, right? Am I doing this right? Right, x, right? 8x. And then this is going to be 16x. And then this is going to be 32x. The area of the shaded rectangles. So, and then we could just sum all of these, but we also know that this is half of the entire rectangle, right? This rectangle right here. So the entire thing is 64x. This times 2, right? Because this makes up half of the entire thing. So the entire thing is 64x. So x is going to be 1/64th of the entire rectangle. There, that's it. All right, number 12. Oh no, I'm almost out of time. So I'll do number 12 in the next video.